Use the leading coefficient test to determine the end behavior of the graph and the polynomial function. Your lead coefficient here is 7, but the most important thing is that 7 power you have there. Odd powers, the graphs will start low and do some work, and then they'll finish high. Okay, you would like to see with a 7th that you have 7 x-intercepts. That's most likely not going to happen. But it's a positive 7, so it'll start low and finish high because with the odd power. So your behavior is we're going to be falling over here to the left, fall left, but we're going to rise right. And that will be D. Find the maximum number of zeros that the polynomial function can have, then use Descartes' rule of signs to determine how many positive and how many negatives. Well, the maximum number is always going to be based on that highest power there, the degree. So we're looking at 3 for the maximum number of zeros. How many positives we have? What you want to do to figure that out is look at the original and see how many sign changes you have. So we're starting with a negative, we have a negative, we have a plus, so there's a sign change, and we have a plus. So we have a grand total of 1 sign change. So you have 1 possible positive real answer. Now if you end up having 2, 3, 4, then there's something you have to do. You have to reduce those answers by an even number, which just means you have to take 2 away. So if you had, let's say you had 2 sign changes, then you would say, well, I have 2 positives, but if I take 2 away from that, I could also have 0 positives. So you would have the potential for either one of these positive answers. Okay, let's take a look at the negative real. To figure out the negative, you go through and you make your x its opposite. Clean up the math and look at how many sign changes you have. So the cube is going to leave that negative as a negative. The negative and then the negative with the 6, so it becomes positive 6x cubed. The square is going to make that negative back to a positive, minus 2x squared. This will be a minus x, and that'll be a plus 4. So your sign changes. You have a plus, you have a minus, minus, and a plus. So we have 1 sign change here, 1 sign change here. That's 2 sign changes. If you have 2, 3, 4, or more, then you reduce that result by an even number, which means you reduce by 2. So if you have 2, you could also have 0. So the number of negative answers possible could be 2, but it could also be 0. The following function is given. List all possible rational zeros. So we take factors of the 22 and we divide it by factors of the 1, so we won't have to worry about that. So with 22 we have positive negative 1, positive negative 2, positive and negative 11, positive and a negative 22. So there would be your list of possibles. Use synthetic division and let's find one. So let's go with a 1. We'll bring the 1 down. 1 times 1 is 1. We'll put it here. We'll add. 1 times 3 is 3. We'll put that here. We'll get negative 8 when we add. And 1 times negative 8 is negative 8. And no chance. Try negative 1. Bring your 1 down. Negative 1 and 1 makes negative 1. We'll add those together, we get 1. 1 and negative 1 make a negative 1. We'll add those together, we get negative 12. 1 and negative 12 make a positive 12. No way. Let's try the 2's. Scroll. Scroll. 1 and 2 make a 2. We'll put that together. We'll add. 2 and the 4 make it 8. We'll put that together. We'll add. 2 and the negative 3 makes negative 6. Nope. It is not working for me today. There we go. Let's try negative 2. Negative 2 and 1 makes negative 2. We'll add those together. Negative 2 and 0 makes 0. We'll add those together. Negative 2 and negative 11 make positive 22. Perfect. Negative 2 is one of our solutions. We had x squared. What was the result? X squared minus an 11 was the result. I would solve this by taking the 11 and adding it to the other side, and then I would take the positive and negative square root of that 11. So our solution set, negative 2, negative square root of an 11, positive square root of an 11.